This is the A to D extension of the previous YouTube video. It's based on the assumption that you have previously watched our 2015-2. The data sheet is necessary in order to work with this chip. The control byte determines which of the four A to D inputs is used. These two bits have to be 0. Bit 6 is 0 for the A to D function. These two bits are 0 for single-ended inputs on all four channels. These two bits have to be 1-1 for activating the A to D on channel 3. Bit 2 is 0 for reading only one channel. This is the control byte for reading channel 3 single-ended. Here is the control byte as defined in the C program. Here it is transferred to the right buffer. The 2 bytes will be read from the chip. The input voltage will be calculated. Chip initialization is similar in the previous video. The slow bus speed shows less noise on the oscilloscope traces, which will be shown next. It may be possible to use the read-write command instead of the next 3 commands. Finally, the control byte is written, and then a delay, and then 2 data bytes are read. The A to D bytes are moved into integers. Voltages are calculated. The 2 A to D bytes are printed. The 2 integer counts are printed. The 2 voltages are printed. The program ends. The program is run 2 times. First time with 0 input, second time with 3.3 volts input. 2 bytes are read because the second byte contains the current reading. Finally, we'll examine the bytes on the oscilloscope. All the bytes are shown here. That's the chip oscillator, the data bits, and the I2C clock. The first byte contains the chip address. The first byte also indicates write mode because the next byte is the control byte for the subsequent A to D mode. This is the control byte for the A to D mode. This shows the 200 microsecond delay and the first part of byte 3. Byte 3 has the chip address and also indicates A to D mode. Byte 4 contains the first data byte, which is all 0. The last data byte contains all 1s. Excellent agreement was observed between the input analog voltages and the subsequent digital values in the Raspberry Pi.